Okay, so we'll be continuing our discussion on the next quantity, kinematic quantity. We have the value acceleration. Okay, so in terms of symbols, we have the symbol for the acceleration, a small letter A, and again, acceleration is a vector quantity, and it is defined as the rate of change of velocity of a body. Take note of this definition. The definition of acceleration is the rate of change of velocity of a body. It's velocity, not speed. So it is important for you to get the difference. It is the rate of change of velocity. It is not velocity, not speed. Okay, so let us try to illustrate that definition using this illustration. So what you see here is that you have a car that is initially moving at 5 meter per second, and at a later position it is now traveling at 15 meter per second. Obviously the car increased its speed for the given time interval between the first position and the second position, which is 2 seconds. So from that interval of 2 seconds, the car's speed increased from 5 meter per second to 15 meter per second. Now, in terms of magnitude, we are referring to 5 meter per second and 15 meter per second as speed. But if we're going to describe it in terms of velocity, it would be 5 meter per second going towards the right direction. It would be 15 meter per second going towards the right direction also. Now, since there is no change in direction, the car is simply moving towards the right, then it would suffice at the moment that we just refer to 5 meter per second and 15 meter per second as speeds, since the both situations the car is simply moving in the same direction. So the question now is how much is the value of the acceleration of the car when it increased its speed from 5 meter per second to 15 meter per second. Okay, so now the in terms of the formula, how do we compute for the acceleration of an object? We simply get the difference between the final velocity or the later velocity minus the initial velocity divided by the time interval between the changing of the velocities from its initial value to its final value. Okay, so what as you can see on this illustration, the final velocity or the later velocity is 15 meter per second towards the east or towards the right, minus the initial velocity, which is 5 meter per second towards the right, divided by 2 seconds. So you have actually 15 here minus 5 gives you 10. 10 divided by 2 seconds, so that you have 10 meter per second divided by 2 seconds gives you 5 meter per second squared. Okay, so how did we get the unit meter per second square? The unit of the velocities above the fraction is obviously meter per second. So you have actually meter per second divided by the unit of time, seconds. So you have actually meter per second divided by seconds. So in order to get the meter per second square, remember your division of fraction. Division of fraction, you copy the upper fraction. So you copy meter per second divided, you multiply it with the reciprocal of the lower fraction. Since you have seconds as your lower fraction, you get the reciprocal of that. That becomes 1 over seconds. So you have meter over second times 1 over second. So that means second times second becomes second square. So meter over second square. Okay, so these are the corresponding meaning of each symbol. So V sub O is the initial velocity, V is the later velocity or the final velocity, time is the T is time elapsed in seconds, and acceleration is your letter A. Okay, so consider the following notes. V sub O is 0 when the body is initially at rest. So when it is mentioned in the problem discussion that an object is initially at rest, it already implies that the initial velocity is 0. The problem does not need to mention that the value of the initial velocity is 0, it is understood when it is said in the problem that initially the object is at rest, the object, obviously the velocity initial is 0. Okay, also take note that when the problem discussion states that the object stops moving, then it follows that the later velocity or the final velocity would be 0. Okay, so another note, when the problem discussion states that when the body is moving at constant velocity, that means the object is not changing velocity, then it follows the value of the acceleration is 0. Since the definition of acceleration is the rate of change in velocity, it is required that velocity changes. If the problem discussion states that the velocity is constant, then it is not changing. Therefore, the acceleration is actually 0. Okay, so in terms of the direction of the velocity, when the body moves along the positive x direction and the positive y direction in our usual Cartesian coordinate system, remember in our Cartesian coordinate system, from the origin moving to the right is positive, from the origin going upward is also positive. Going to the left of the origin and downwards from the origin is designated a negative sign. So therefore, when we try to illustrate a given problem and it is said in the problem that the body moves along the direction of the positive x and the positive y, then the associated direction for the velocities would be positive. Otherwise, it is negative. Okay, so just like what is said here, when the object moves along negative x and negative y, then the direction associated with the initial and the final velocities is negative. Okay, when the body is accelerating, the initial velocity and the acceleration have the same direction or sign. When the body is decelerating, the initial velocity and the acceleration are in opposite directions or signs. Okay, so let me introduce another term here, the word deceleration or decelerating. The idea is that if the velocity increases, you have a positive value of the acceleration, and we call that acceleration. Now, when the object slows down so that the initial velocity is actually greater than the final velocity, then you will have a difference of v minus v sub o as negative. Then, since obviously it is the object is slowing down, then therefore we have a negative acceleration, and we call negative acceleration as deceleration. Okay, so next in our discussion is the concept of the average velocity. Okay, so the average velocity is defined as the displacement divided by the time interval during which the displacement occurs. So it is the displacement divided by the time. We usually choose an origin, then locate the initial and final positions of the object within specified time intervals. So for example, as you see in the illustration, the location of the position of the car from the origin is x sub 1, and the location of the position of the car at the second location is x sub 2 from the origin also. So x sub 1 from the origin, x sub 2 from the origin. Now, of course, the displacement is the change in position. So that means when the object changes position from this position to this position, then that measure of displacement is simply the difference of x sub 2 minus x sub 1 gives you this displacement. So therefore, delta x here, or the change in x, is simply x sub 2 minus x sub 1. Okay, so given the displacement delta x, if we're going to divide that with the time interval between the initial position and the final position, obviously that is time t sub 2 minus t sub 1. So we have delta x over delta t, or x sub 2 minus x sub 1 divided by t sub 2 minus t sub 1. Then that would result to a computation of the average velocity. Okay, so just like what we see here in this set of equations, the average velocity is actually the change in x over change in time, where in change in x is the general symbol for the displacement. When the motion is along the x, we make use of x. When the motion is along the y, we make use of y. Okay, so take note of the following discussion. If the body if the body is at time t sub 1 or the initial time, then the body is said to be at the origin if it is specified in the problem. Otherwise, it would be at a different location. If the body is at time t sub 2 is at the origin, then x sub 2 is at the origin, x sub 2 is 0, and y sub 2 is 0. If the average velocity is positive, then the body moves upward or to the right. If the average velocity is negative, then the object moves towards the left or the downward direction. When the body returns to its original position, then the time interval, then the average velocity would be 0, since you have a 0 displacement divided by time gives you 0. Okay, so let's consider the next quantity, which is the average acceleration. The average acceleration, just like what we have done with the average velocity, it is somewhat similar. Okay, so in by definition, we have the definition of the average acceleration. It is the change in velocity divided by the time it takes for the change in velocity to occur. So that is delta v over delta t. When the rate of change of velocity of a body varies as it moves, we can compute for the average acceleration for any specified time. So just like what we did with the average velocity is x sub 2 minus x sub 1 over t sub 2 minus t sub 1. Now this time, average acceleration, we just replace x sub 2 with v sub 2, and we just replace x sub 1 with v sub 1. So that is delta v over delta t. Okay, so just to illustrate, if we have the same car that is moving between the intervals t sub 1 and t sub 2, and perhaps it increased its velocity from v sub 1 to v sub 2, then the average velocity is simply v sub 2 minus v sub 1 divided by t sub 2 minus t sub 1. Okay, so take note of the following. If v sub 1 is equal to 0, then the body is said to be the body started moving from rest. Now again, v sub 2 is equal to 0. If the final velocity is 0, then it is said to be that the body stopped moving. Okay, so let's consider sample problem. A car from a signpost initially at rest moves to the east. After 2 seconds, it is 20 meters east of the signpost. Then after 10 seconds, it is found that it moves 60 meters from the signpost. Then the question is, what is the car's average velocity during the time interval 0 to 2 seconds, 2 seconds to 10 seconds, and from 0 to 10 seconds? Okay, so let's go through with the solution for this given problem. So this is the same problem that we have posted using the PowerPoint. So let's try to have a list of all of our givens. Okay, so it is said in the given problem that the car is initially at rest. So what does this mean? Initially at rest, that means our initial position x sub 0 is at 0 meters, meaning the car is at the location of the signpost where all measurements was measured. The car moves towards the east. Then after 2 seconds, 2 seconds is a later time. Our initial time is t sub 0. 0 seconds when the car is at the signpost. T sub 1 is 2 seconds. The car is 20 meters east of the signpost. So t sub 1 partners with x sub 1 20 meters east of the signpost. T sub 0 partners with x sub 0. And t sub 2 partners with x sub 2. So what is t sub 2? After 10 seconds, therefore 10 seconds is a later time. So we assign t sub 2 for that later time, 10 seconds. the car is found to move at 60 meters from the signpost. So 60 meters would be the position at time t sub 2, 60 meters east of the signpost. The car is initially at rest, so therefore our initial velocity is 0 when the car is at the location of the signpost. Okay, so let's go through the solution. What is the car's average velocity at the given time intervals? Okay, so these are the solutions. So for letter A, the average velocity between the times 0 seconds and 2 seconds, this is average velocity. So this is actually displacement. This is displacement over time, so that is delta x over delta t. This is x minus x sub o as a generic solution. This is actually x sub 1 minus x sub o. So okay, so this is x sub 1 minus x sub 0. This is t sub 1 minus t sub 0. Okay, so x sub 1 minus x sub 0, t sub 1 minus t sub 0. So the givens are the following: 20 meters, x sub 1, 0 meters, x sub 0. T sub 1 is 2 seconds, t sub 0 is 0 seconds. So that gives us 20 minus 0 gives you 20, 2 minus 0 gives you 2, 20 divided by 2 gives you 10 meter per second as the total, or the change in velocity, or the average velocity. So that is displacement over time. Okay, so doing the same for the next time interval, we have between okay, so next would be between 10 seconds and 2 seconds. So 10 seconds and 2 seconds. So this means this is actually x sub 2 minus x sub 1. Okay, so x sub 2 minus x sub 1 over t sub 2 minus t sub 1. So that is our givens are correspondingly, we have the following: 60 minus 20 over 10 minus 2 gives us 40 divided by 8 seconds, so that gives us 5 meter per second. Okay, so finally from 0 to 10 seconds, so that is okay, so that is x sub 2 minus x sub 0, t sub 2 minus t sub 0. So 60 minus 0 over 10 minus 0 gives us 60 over 10 gives us 6 meter per second. Okay, so let's have the second example. A car starts from rest and reaches a final velocity of 40 meter per second in 10 seconds. So what is its acceleration? Letter B. If its acceleration remains the same or remains constant, what will its velocity be after 5 seconds later? Okay, so for the solution for the second example, we have this is the same example presented in the PowerPoint. So let's go through with the givens. It is said in the problem that the car starts from rest. So what does that mean? The car starts from rest. That means its initial velocity v sub 0 is 0. The car is initially at rest. It reaches a final velocity of 40 meter per second. So our later velocity is given as 40 meter per second. The time it takes to cover 40 to speed up to 40 meter per second is 10 seconds. So t sub 0 would be 0, t sub 1 would be 10 seconds. And finally, we have in question letter B, if the acceleration remains the same, what will its velocity be 5 seconds later? So this is actually 5 seconds on top of 10 seconds. So that means t sub 2 is actually 15 seconds from the initial time 0 seconds. Okay, so let's go through the computation. First is what is its acceleration? The acceleration is the average acceleration, which is delta v over delta t. So that is v sub 1 minus v sub o over t sub 1 minus t sub o. So this is actually t sub 1. Okay, so v sub 1 minus v sub o over t sub 1 minus t sub o. So, that is given as 40 minus 0, 10 minus 0 gives us 40 divided by 10 gives us 4 meter per second square. Okay, so next would be letter B. If the acceleration remains the same, so what does that mean? Before we proceed with answering, what is meant by the acceleration remains the same? It means that the average computed acceleration remains the same. That means the value of the average velocity is equal to the instantaneous the value of the average acceleration is equal to the value of the instantaneous acceleration. Or simply, it is what is meant by the acceleration remains the same is that the average value is equal to the instantaneous value, or simply we drop the subscript average. Okay, so given that A is equal to delta V over delta T, and V minus V sub O over T minus T sub O becomes V sub 2 minus V sub O over T sub 2 minus T sub O. For the later time, 5 seconds on top of 10 seconds. So what is asked here is that we are asked for the velocity after. So that means in our set of givens, we're actually looking for V sub 2. So from here, V sub 2, we solve for V sub 2. We just cross multiply T sub 2 minus T sub 0 towards A. So that is A times T sub 2 minus T sub 0. What is left here should be V sub 2 minus V sub O. Now, to isolate V sub 2, we must transpose negative V sub 0 towards to the side of the acceleration, and that gives us positive V sub O. Therefore, we have V sub 2 is equal to 8 times T sub 2 minus T sub O plus V sub O. So simply, this is a direct substitution problem. V is 4 meter per second, 15 minus 0 plus 0 gives us 60 meter per second. Okay.